Hello everybody, and greetings from the Delta College Planetarium. My name is Brian, and I'm here to bring the next episode in our continuing series about the constellations. Last time we examined Andromeda, the princess of ancient Ethiopia who is being offered as sacrifice to the god Poseidon. This time we look for the hero that rescued Andromeda from the clutches of the sea monster. As always in the autumn, we begin with the autumn square, the set of 4 stars high overhead that make a nearly regular square. Remember that the upper left star in the square represents the head of Andromeda. Andromeda's body is formed by the V shape of stars that radiate to the left. The constellation that we're looking for is just past the ends of that V, the feet of Andromeda. The hero Perseus is difficult to see because, well, he doesn't really look like anything. To my eye, Perseus is a coherent river of stars that ends in a hook and has 2 branches sweeping off to the sides. I've heard people say that Perseus looks like an umbrella, or maybe like a hat-wearing witch in profile. While people report seeing different images in Perseus, I've never had anyone tell me that they saw a person in those stars. Perseus is a hero of ancient Greek mythology. He is principally connected to 2 stories, which collide together here in the night sky. Most relevant to our celestial tableau is that Perseus happened to be flying by when Andromeda was chained to the rocks, and he was naturally curious why anyone would be chained in the harbor. Upon realizing that Andromeda was threatened by a sea monster, Perseus slew the monster and rescued Andromeda. How did Perseus slay the monster? Well, that brings us to the other story. Perseus had been returning from his first quest when he happened upon Andromeda. He had just slain the Medusa, the monstrous Gorgon. Half woman, half snake, with serpents for hair, the Medusa possessed the power that whoever looked upon her directly was turned to stone. Clever Perseus used a mirrored shield to defeat the Medusa, and removed her head as trophy. The head retained the power of petrification, so he hid it in a bag. When the sea monster attacked, he removed the head, turning the sea monster to stone. Medusa's head is represented among the stars of Perseus by the star Algol. Algol is a red star near the end of one of the arms of Perseus, and has the peculiar behavior that it changes brightness. Typically, Algol appears to be relatively bright at magnitude 2.1, but every 68 hours it dips to magnitude 3.4. Only about 1/3 as bright. What's going on here? If we take a look at the spectrum of Algol, we see the same sort of cyclical Doppler shift that we observed around 51 Pegasi. This should start to get us thinking about the star probably moving in a circle. The next clue comes from looking at how the intensity of light from Algol changes with time. When astronomers measure the intensity of a star's light, a procedure called photometry, the resulting chart of how the intensity of the star varies with time is called the light curve. In the light curve of Algol, we see the expected dip every 68 hours, but curiously, there's a second dip. This one is much less intense, such that you wouldn't notice it by eye, but sensitive instruments can detect it. So in one cycle, Algol starts at a level, dips a lot, comes back to the level, dips a little, and then returns to the original level. Something is blocking the light from Algol every 68 hours. Okay, so let's start putting the clues together. Algol's spectrum is going through a Doppler shift cycle. We've already seen how that can indicate that something is orbiting a star. So something is orbiting Algol, and from the cycle of shifts, we can know exactly how long it takes the object to orbit Algol, and through a little bit of math, how far away that object is. Then we look at the light curve, and we can see how much the light dips, so we can start to figure out the size. So whenever this object passes in front of Algol, the light dips by a lot. But whatever it is, when Algol blocks it, the light also dips. This object must be giving off light. And it's through this chain of reasoning that astronomers conclude that Algol is a binary star, 2 stars orbiting each other. These are special though because just through random chance, the plane of their orbit happens to line up with the Earth. We can see the stars eclipsing each other every 68 hours. Just above Perseus's head, under dark skies, sharp-eyed observers may see 2 close together collections of stars. These are the Perseus double cluster. Each of these is an open cluster of stars. Open clusters differ from globular clusters in that they are, well, open. They are more loosely held together than dense, compact globular clusters. All of the stars in these clusters formed from the same cloud of gas and dust. They're only weakly bound by gravity, so over time these clusters will tend to spread out and break apart. The double cluster is very young, having only formed about 13 million years ago. The Perseus double cluster is an excellent deep sky target for amateur astronomers with a modest telescope. So if it's clear where you are tonight, go out and look for the mythical hero Perseus up there among the stars. Take a glance for Algol, and make a note of how bright it is tonight. If you have a small telescope, take a look at the stars of the Perseus double cluster. That's it for today. Next time we'll continue our exploration of the fall sky. This is Brian from the Delta College Planetarium, wishing you clear skies.